Hello, everyone. I didn't expect applause at the beginning. Maybe I will deserve it at the end, but thank you anyway. So it's nice to see you here. I didn't expect this crowd, to be honest, but I'm glad that you're all here. So what I'm going to talk about today is how we built our backend using microservices with Event Bus at adjoe. But before I begin, I would like to introduce myself. I am Irina. I am Irina, and I am tech lead at adjoe. I have been in the software industry for much longer than I would like to remember. So I will just hint that I started in the previous century. And I have been a backend developer for all my life, and I hope to remain one. But before I dive into why we built our backend the way we did, I have to explain you what is adjoe, what is the business model behind, so that you can understand why we made some choices in building our backend that we made along the way. So adjoe is a fast-growing ad tech, already a scale-up. And before you start thinking, oh, again, another ad tech company that bombards me with ads on my mobile device, for which we have a special place in hell, let me tell you that this time it's a little bit different because we have our own rewarded formats. What that means is that our targeting the users that we are targeting is actually people that like to play games on mobile phones. So what we do is we are connecting on one side advertisers, and these are the authors of the apps that want to acquire new users, which means they want to have you install their game on your mobile phone. It's usually games, the apps we're talking about. On the other side, we have monetizers. These are, again, application publishers that want to earn money from displaying ads in their applications. So we are the platform in between that connects these sites. And what we do, we actually show the offer wall of the apps you can choose to install. And then when you do that, you get rewarded for the time you spend playing these apps in the monetizer's application, or because you passed level in the game and you need some currency in the app from which you are coming. So this is the business model. The company is fast growing, and it actually started scaling around 2020. We are handling with like enormous load. Just to give you an idea, we are currently processing around 5 billion API requests per day. And we also collect huge amounts of data. Why? Because we want to show you the games you are interested in. Like, we don't want to show you just some random games. We don't want to show you games you already have installed in your phone. We want to target you with like the games that you will likely install. And so we have a huge user base, which is around 500 million mobile devices. And if you are a user of any kind of rewarded apps, it's highly likely that you have us in your phone. And we also have, as I mentioned, monetizers on one side and advertisers on another side who also use our platform. Why? Because monetizers have to install our SDK to connect to our backend. And on the other side, advertisers are sending us events about the install of the game, about all kinds of events, in-app events that happen in the games that we then process. So just to give you an idea, from where is this like huge load coming from? And going up like this just reassumes what I just said. So we have different SDKs that monetizers install in their applications, mobile applications. We have advertisers that connect to our backend and send us all kinds of events. And then we also have dashboards because, as you may imagine, both advertisers and monetizers need to be aware of like how their business is performing. Are they earning enough money from advertising? And all kinds of optimizations they want to do when they do their business. So for that, we have built the dashboards, and you can imagine we have to do all kinds of aggregations of events to be able to show them like the statistics and KPIs they care about, and also the trends over time. So do we have any Go developers here other than my folks at adjoe? Oh yeah, so just for you to know, we are hiring. So our backend is built exclusively in Go. We have around 300, more than 300 services, and we are talking about 2.3 million of lines of code written in Go. So why Go? First, it's compiled, it's fast. Some say it's simple. I would maybe disagree, but you can't deny that a code base written in Go is very readable if you write it the idiomatic way, and also very maintainable. So that helps us ramp up new developers quicker, let's say. So for us, it turned to be like a really good choice. Our code is kept in monorepo. We have a structure which is like folder per service, and we have owners of services, so different teams that own different services within monorepo. But again, we also have the shared code, as you can imagine. So for example, definition of events that we are receiving have to be like shared between different services, because we will have, as I will talk about in a bit, publishers and subscribers. All of these services are deployed together. But we put a lot of effort into not making this some sort of tangled mess. So like we take care of our code, and whoever like is a developer here, and as I think most of you are, will find a pretty much standard structure in our monorepo. So when we develop microservices, we have controllers that receive requests. We have services that do some kind of application logic. Then we have models and repositories which deal with the persistence layer. And we have handlers for the events. And I will come to that later. But before that, I will just give you a bird's eye view of how our backend looked like, and then I will discuss why did we make some choices and which ones turned to be good and which one maybe not so. The backend services are Dockerized and deployed on EC2 instances. We use extensively AWS infrastructure yet. We use ECS for container orchestration, and of course instances have auto-scaling enabled. And as far as the persistence layer is concerned, as you can see, we use a wide range of databases for different purposes. Why? Because, for example, we use relational database, which is Aurora, for keeping all kinds of configurations, like for the campaigns or ad display, let's say. Then for services that have to scale, we use DynamoDB extensively. For in-memory cache, we use Redis. And for producing statistics, we recently started using Druid. I will talk about this a little bit. And we are moving away from Redshift, which we previously used for aggregating data. And as I said, we are still pretty much reliant on AWS infrastructure for, as you can see, many of the infra details that I talked about, but we are trying to move away from it using many of the open source technologies, and I will mention some of them. For example, Apache Druid is an open source. One really peculiar characteristic of our deployment is that we use exclusively Spot EC2 instances for deployment, even for databases. And my colleague Farhad had really interesting talks this year and last year in which he explained how they do it. But the bottom line is that using spot instances, which if you're not really familiar with it, it's like instances you can rent from AWS when they have it available. They are like much cheaper, but they can disappear like with 2 minutes notice. So of course, that means that all microservices are stateless, as you can imagine. But using Spot, EC2 instances allows us to achieve 90% savings on infrastructure. And then back to events. With this scale of events we have, you may imagine that direct communication between microservices would be impossible. So what we do is we decouple them using the event bus. And that was the choice that we implemented from the very start, very beginning. So what happens? Like, what is the anatomy of our microservice? We get the request, we do some kind of logic, and then usually produce event to event bus, and on the other hand, store the state in some persistent storage. And we also have a lot of consumers that actually don't receive HTTP requests, but they receive like event, then they, for example, aggregate it and then publish another event. So you will see a lot of that in our code. Why did we choose to go with this? As I said, it's impossible, like synchronous communication between microservices with this scale of events that we are receiving and requests is just not an option. So we had to go with event bus to achieve decoupling between microservices. And what we also get from this is that sometimes we produce a single event and we have multiple subscribers to the same event, which lets them, like the subscribers, process messages in parallel and independently. And we are also achieving scalability because when the load increases, we can also easily scale the consumers of the events. To implement this, we extensively use publish, subscribe, fan out pattern with SNS and SQS queues, which would probably be maybe familiar to some of you. So the event comes, we publish it to SNS topic, then to this topic we have a couple of SQS queues subscribed, and then we have handlers that I mentioned that actually process messages from the queue. And the nice thing about this SNS SQS pattern is that, for example, things come for free, like FIFO queues, or you can filter the messages from the topic, like you don't have to consume all the topic, you can just filter the messages you're interested in. And it's highly reliable. So just to give you an idea, like the queues that are under the highest load, I think consume around 5 million messages per day. And then I mentioned Dynamo. So we use DynamoDB table per service, which is, as you know, like a good architectural pattern, like every microservice should have its own tables. In this case, we usually have multiple DynamoDB tables per service. And the same event can end up in different Dynamo tables in different services with tables having different layout. Because you have to think beforehand, how are you going to query this DynamoDB table? As you know, this is not a relational table, it doesn't support joins. So you have to think ahead, what kind of primary and sort keys are you going to design for this table, and how are you going to put items to this table so that you minimize the number of writes and reads to this table, because of course you want to save on pricing. What we also have extensively implemented is the TTL, or time to live. So we expire items after a certain period, which depends on the usage of the table, again, because we want to save on price. Back to the dashboards. Remember, I told you that we have dashboards for advertisers and monetizers, where we display all kinds of statistical KPIs for them, which means that we have to aggregate events like clicks and views and installs and everything around this. We have to show them data in near real time. For this, we recently passed to using Apache Druid, which is a real-time analytics database, open source. Why? First, because it allows fast ingestion. So millions of records per second are ingested, and now we do it through Kafka queues. So we don't longer use SNS SQS pattern for this, but we use Kafka. And then what Druid also allows us to do is to do so-called roll-ups or pre-aggregations of the events without any actually additional development effort. So the data gets consumed, aggregated, and then saved to Druid, which then allows Druid to have sub-second response times, very, very fast. And also allows like multiple users to issue queries at the same time, so concurrent use, which is not the case with some other real-time analytics databases. And so this is the flow we actually have for generating statistics. Like the service usually generates the event or receives the event, published to Kafka topic, we consume the topic directly, Druid ingests it, and then on top of this, we have the API built, which powers the dashboards, which is actually quite simple because Druid has an API which gives you the response in JSON, so you don't have to do much. You just have to like pass this response to your front end. And this is how like our dashboards look like. So you can see here that besides like statistic, we also show trends. So how did this KPI perform? Like how does it perform now respect to like 7 days ago or 2 weeks ago? Because that's also important to our advertisers and monetizers because they want to optimize, of course. And this is what we get with Druid. But I'm not done. So on top of this, we also have DynamoDB streams attached to tables that we use to propagate historical changes in DynamoDB tables to be used in data lake. So DynamoDB stream is a time-ordered sequence of events, all the changes that happen to your item in a DynamoDB table. And then we export it through Kinesis Firehose and S3 to Athena so that our BI analysts and data scientists can actually use it to do any kind of like analysis or base machine learning algorithms on top of it. And just to give you an idea, this was the flow we had for generating statistics before we actually started using Druid. And why am I showing you this? Because it uses AWS tools, and you can pretty much see how complicated it is and in how many places it can go wrong, and it can also be expensive. So just because you have like a hyperscaler like AWS available doesn't mean you have to use it. Like when all you have is the hammer, like everything is a nail. So why don't we just use like a little bit of Redshift and then we just use SNS SQS and Firehose and copy to Redshift and S3 and the things pretty much easily get out of control. And finalizing this review of how our backend is made, some words about observability, actually 2 pillars of it, metrics and logging. Tracing is missing because we don't actually have full tracing in place. What we have is like manually generating traces, but we are not able actually to do the sequence of events. Like we just propagate the trace from the beginning to the end, but we are not able easily to reconstruct the flow of the event through the system. And that was one of the initial mistakes. But on the other hand, we have a really good logging, structured logging. We use FluentBit as the log shipper and OpenObserve to keep logs for a longer time. Again, another open source tool. And on top of it, we have Elasticsearch and Kibana that we use for exploring logs. And these logs are actually events like with a lot of information. For monitoring, we used to rely heavily on CloudWatch. But with this trend, like adjoe is scaling, we acquired a lot of knowledge, like from the beginning to this phase now, where we have much higher load and much more knowledge. So we are again moving away from AWS tools and starting to use extensively Prometheus and Grafana for monitoring. And then we have a robust not alert, but in this case, Sentry alerts us about critical application errors, but we also have like many alarms in place. So what happens is that whenever something goes wrong in production, we get notified really quickly because of all these alerts that we have in place. And we are also able to roll back the change we did like really quickly. And this concludes my overview of how the backend is made. And I will just briefly walk you through some lessons that I think are valuable from our experience. So when dealing with such high load, I don't think you actually have any kind of other architectural pattern to implement other than event bus. Because as I said, synchronous communication is really not an option. But it's not all bells and whistles. So you have to think about all these queues you put in place and how to ensure fault tolerance, for example. So sometimes, like, messages get to queue, but they can't be consumed. So they end up in dead letter queues. Then you have to analyze what happened and maybe to redrive these queues. Sometimes something goes wrong and you have to actually regenerate events and then replay them and reconsume them. Then the other thing that's maybe a disadvantage of this pattern is that you have to live with eventual consistency. So we don't actually have a problem of distributed transaction between microservices, like chain calls of services that all have to pass for the transaction to be actually executed. But we replaced it with eventual consistency. So one consumer will process the messages, some other maybe will get stuck, but that will not tear our system down. Eventually, they will be consistent, like data will be consistent everywhere, but you can't expect this to happen all the time. For example, in the case where you have high backlog of events to process, so there will be some latencies. You have to deal with that. You have to live with that. But that's not all. So when introducing these events and event bus, event-based architecture, you have to be really careful about like the code and how it's organized and where do you keep all this stuff, because it becomes really complex. Like for a new developer joining adjoe team, not only we have a monorepo, which then means that you have to get like accustomed to this huge code base we have, like you just can't figure out service by service. You have to like ingest it all at once. You also have to deal with this complexity of events. So event gets generated in one place and then consumed in 3 different places. But monorepo in this case helps because you can find it, like you can trace it. But in general, like it's more complex to handle. Root cause analysis is difficult, especially when you don't have like a really good tracing in place. So you have to debug, like follow the flow, and sometimes like you introduce a change in one part of the system that has consequences in some like totally unexpected places. So you have to be able to debug, and that's also difficult, like much more difficult in this kind of architecture. So there is an additional effort, a cognitive load that's required in this case. Regarding using DynamoDB, what came to bite us is the price, of course, because you pay for the storage and you pay for read capacity and write capacity units, so for reads and writes to Dynamo. And I can tell you that the largest share of our AWS infrastructure costs is Dynamo, which is not surprising. And I won't tell you like how high is our account, but you can imagine. And what we recently also encountered is that Dynamo has the limit on the item size you can store in it. It's 400 kilobytes. And we already in some cases like are higher than that. So what we are forced to do is think of a way to split an item into multiple items so that we can actually then like consume it. And that's really not nice and it's expensive. The same thing with using SNS and SQS. So it's all bells and whistles until you hit like the large scale. And then of course your like bill skyrockets. So with this number of messages that are flowing through the queues, again, SQS becomes really, really expensive. And also that like recently we also hit the limit. So the SQS message has a limit size of 256 kilobytes, which we somehow managed to surpass. So again, like these kind of problems are now bugging us. And that's the reason that we are slowly migrating from fan-out pattern implemented with SNS SQS to Kafka. But again, it's not all bells and whistles. Not only we have to live with a code base that publishes sometimes simultaneously both types of queues, because we use Kafka for statistics and we still use SNS SQS in some legacy code that was written. For example, we had the problem that sometimes publishing to Kafka fails. So what we did is we implemented fallback queues. Like when publishing to Kafka fails, we publish to SQS, and then try to republish message to Kafka, try a couple of times, and then if it fails, it ends up in the dead letter queue. So again, fault tolerance in place. So the things are really starting to be chaotic. We are in the phase where we are trying to reduce this technical debt and like remove SNS SQS, also because we don't want to be like, we want to reduce this dependency on AWS, but I can tell you it's not an easy job. And some thoughts about observability, as I already mentioned, like it's good to invest in traceability from the very beginning when you're dealing with events. And there are like open source tools that are now really available, and you can actually host them yourself with a moderate effort, like open telemetry. You have to implement the robust logging system, like you can't live without it. And as I already mentioned, like try to use open source tools if you can, because Prometheus is also like industry standard. There is no reason like to go to CloudWatch now if you have enough knowledge and like resources to use just like Prometheus and Grafana. And some closing thoughts. You can't really implement any new feature without taking into account the infrastructure. So at adjoe, development and infrastructure is really closely coupled. Like so coupled that we developers are actually writing Terraform code. Like we use Terraform as infrastructure as code. So we write code whenever we want to like add some infrastructure resource, and then like the DevOps team just helps with it. But often it happens that when you design something, you first have to think about, oh, how much is this going to cost? Like, should I use maybe Kafka, or should I, or like maybe it's not going to be that expensive. So it's not just like, okay, I'll just code this and like push it to production and hope for the best. You have to think about how much it's going to cost and what consequences it's going to have on infrastructure. And this seems like blah, like I've seen this a million times, like blah, but it doesn't hurt to mention it again. Okay, you are just starting, so it's only logical that you will choose a hyperscaler like AWS and use the tools you have at your disposal. And I'm not saying it's all wrong, of course, like there are tools that like are good to use. But then again, don't just blindly use them without thinking of how, like, in what direction will your application evolve, actually. Because there might be some open source tools that are even better and will cost you a lot less. So it doesn't hurt, like, to keep an open mind. Like, don't just use AWS because you have a hammer. Like, use the best tool for the purpose if you can. And again, architecture decisions, there is no one size fits all. You have to know what beasts you are dealing with. Like if you're dealing with events at this scale, I mean, you can't just escape it, but maybe this is not the right pattern for your case. So be really, really cautious. These are some decisions that are made at the beginning, and then, like, if you want to reverse it and like go back, it's going to cost you a lot, like in development effort, in any kind of like price you can imagine. So that's just like the final thoughts of what I can tell you from adjoe's experience. And here, for those who are interested in architecture, I just wanted to mention these two books. You probably know about them if you are interested in this topic, but it doesn't hurt because this is distilled knowledge of like everything that I just described you from the trenches. And of course, there is adjoe's engineering blog where we talk about stories. So if you want to know anything in more detail, I just recommend you to go and look what we have there. And that would conclude my today's talk. If you want to connect, you can just scan this QR code and connect with me. But otherwise, that would be all that I had for you today. So if you have any kind of questions, I'm here